In the last tutorial, we developed a dynamic stack of integers with the push and the pop operation. All are well written, and now we are going to use these operations in order to find out the binary equivalent of an integer number. So for that purpose, we are going to develop this function print binary that's going to receive an unsigned integer, and the binary equivalent of that unsigned integer is to be printed into the console. So the logic for conversion is pretty simple. So we have this number 10 in decimal integer format, and we need to convert it to the binary. So we need to just divide this number with the base of the binary numbering system, that's 2, and we need to collect the remainder each time, and at the end we need to print the remainder in the reverse order. So here is the need for stack. We are going to push the remainder each time into the stack, and then we'll be popping the stack to get the remainder in the reverse order, and we'll be printing it into the console. So first time we get 5 as the result of the division, and the remainder is 0. So this remainder is going to be pushed into the stack because this is the least significant digit of the binary equivalent of 10. So we just cannot print it right now. If we print it right now just after the division, then it's going to be the most significant digit instead of least significant one. That will make us wrong. So we are going to push this into the stack, and then we are going to divide the result of the division again by 2. We need to go on unless and until we are encountering with 0. So we get 2 here, and the remainder is 1. So 1 is going to be pushed, and then again we need to divide by 2. It's 0 as the remainder. I'm sorry. 1 is the result of the division operation and 0 is the remainder. So 0 is going to be pushed, and then again if we divide 1 by 2, it's 0 and the remainder is 1. So finally we get 1 here, and since the result of the division operation is 0, we can terminate the iteration in this way, and then we just go on and print the content of the stack just by popping the stack. So it's going to give us in the last in first out order, so the output is going to be 1010. That's the binary equivalent of the decimal integer number 10. So we are going to implement this. So we need a stack, and we will be using the already developed stack API. So here is our function print binary. Let me declare a stack first, and we need to initialize the stack by calling the init function. Say the size of the stack is 10 initially. Now when it is filled, we know that it's going to be doubled, so we do not need to worry about the overflow. And now we need to iterate as long as the number n is greater than 0. We need to find out the remainder each time. Let me just declare a constant variable here. I'm sorry, let me just declare a constant here. Constant cannot be variable. Okay, so constant int base equals to 2. That is more appropriate. Now we need to push this remainder into the stack, so I'm calling the push operation and passing on the remainder and the address of the stack. So that is going to push the remainder into the stack, and then I need to divide n by 2. That's the base. So that will give us the result of the division operation. Now on completion of this loop, when n reaches to 0 eventually, then we come out of the loop, and then we can just go on and print the binary equivalent just by deleting the stack. So as long as the stack contains element, we should go on. So when the stack is underflow, we should leave. So if the top is not equals to -1, that means the stack is not underflow. So we can just print the popped data. So I'm calling the pop operation and passing on the stack address. That's going to give us the last inserted element. So that's going to print the binary equivalent. Now we need to deallocate the stack because we are done with the stack. So let me go ahead and run the program. I'm calling the print binary with say 10. Then it's going to print the binary equivalent of the value 10. Here we go. Here you can see that the binary equivalent of 10 is 1010. Now here it is printing 0. That's obvious because we are just using n after this while loop. Now while iterating in this while loop, each time we are changing the content of n. So when the control is coming out of the while loop, the n is 0, so we can just keep the content of n in another variable and use that later on. So now this is going to be appropriate. Let me go ahead and run again. So now you can see that the binary equivalent of 10 is 1010. That's correct. Let me test it with some other value, say 18. You can see that it's 10010. Okay, so we are done with the print binary function. Now let me just add two more functions with our stack operations, and that will make it more comprehensive. And they are isUnderflow. To check whether the stack is in underflow state or not, it's going to return true if the stack is underflow, otherwise it's going to return false. And the function is going to receive the stack pointer as usual. And we are going to have another one to check the overflow in the same way. If the stack is overflow, it's going to return 1, otherwise it's going to return 0. We did this checking earlier directly. You can see that here I have used the direct checking, but instead of that, in the push operation and pop operation, I will just call the isOverflow in this way. That would be much more convenient, and I'll pass the address of the stack, and that's here in SP. SP itself is the pointer to the stack object, so I'm passing that pointer to the isOverflow function, and that's going to return either 1 or 0. Similarly, we are going to change it here. And we are going to pass the address of the stack. If the stack is underflow, it's going to return 1, otherwise it's going to return 0. And we can use these functions anywhere else. We can use that here as well. We should pop the stack as long as the stack contains element. Otherwise we should terminate if the stack is underflow. So I can just call isUnderflow, and I can pass the address of the stack here. So that's going to make the program much more convenient. So now let me write this isOverflow and isUnderflow. It should return just a simple one if the top is actually size -1. Now we are just comparing the top with size -1 with the equality operator. Equality operator returns 1 if the equality holds, otherwise it returns 0. So we are returning that value from this function. And similarly we should write isUnderflow. If the top is -1, we know that it's underflow, so we should check the top with -1. And if that happens, it's going to return 1, otherwise 0. So we have added two more functions with our stack, isOverflow and isUnderflow. Before going for execution, we need to check it. It should be not isUnderflow. As long as the stack is not underflow, we should go on print the content of the stack by popping the stack. Okay, so let me go ahead and run the program. It's printing the binary equivalent of 18. So thank you.